episode of the Codebase. If you're joining us live on YouTube, feel free to say hi in the chat, do a little wave. Always nice to know who is joining us. Today, we're gonna do a little bit of something with Clojure. But before we get to that, and before we get to this month's guest, I want to say a couple of words about Codebase. So, Codebase is a celebration of developer communities. It's a celebration of different wonderful technologies and the people who use them. And the idea is that every month, I'm joined by somebody who knows something that I don't. And then together we talk about life, we talk about technology, and then we build something live for all of you to join. Feel free to be active in the chat, ask questions, comment, anything like that. Let's make this a really cozy and casual get together. I want Codebase to be kind of all-way discussion of a conference, not the super prepared talks, but kind of casual discussion and get together with great people. I'm Juhis, I'm the host of Codebase. I run a couple of different developer communities, and on my day job, I work at Futuris as a developer advocate, doing a little bit of more of this. All sorts of community events, newsletters, meetups, stuff like that. Super nice to see a lot of people joining the stream. Today, I'm really happy to be joined by Yrjö Kari-Koskinen, also known as Yrjö. Good to have you here, Yrjö. Welcome.
Thanks. I'm super excited to be here. It was really nice for you to ask me to join. I couldn't say no.
Awesome. So you're a software developer at Tomorrow Tech. You're a Clojurian, and also you host a podcast. So do you want to do introductions to the audience? Who is Yrjö and what do you do?
Oh, let's not spend the whole day talking about that, but maybe shortly. I've been almost 2 years working now for this small startup called Tomorrow Tech, and we are building in Finland this digital trading platform for the residential real estate market, which means that basically making your real estate deals in online instead of going to the bank. And we are building it mostly with Clojure, and it's been super fun. We have a really fun team to work with. And yeah, I'm also have been like almost half a year hosting a podcast, which is called Koodia, pinnan, alla, roughly code beneath the surface. It's like podcast focusing on non-front-end stuff, so stuff that is not visible to the end user and like software development. And we've been hosting it together with my coworker Markus Hjort. And yeah, it's I've been also learning a lot new stuff in the podcast. That's I think one reason to do that as well.
Yeah, doing this kind of, whether it's a podcast or a video or live coding or anything, it's always super nice because it gives you insights into the minds of great people. And now I'm happy that I get to build this side and kind of pick your brain about Clojure and building backend stuff. The funny thing is I realized today that this is not the first time that we're on live stream together. Actually, 2 years ago, I was casting and commentating on a hockey game, and I did an intermission interview with Yrjö. But today we're not gonna talk about hockey. Instead, we're gonna talk about technology, and we're also a little bit less sweaty this time.
I'm sweaty, all right.
Awesome. So, do you wanna tell a little bit about your story with technology and also with Clojure?
Yeah, I've been like working as a programmer for, I don't know, 15, 16 years, like full time, and also doing it like many years before that, like on my spare time and studying and stuff. And I think Clojure is, for me, exciting. I think the first thing is that comes into my mind is that when I started studies in the technical university, the first course in the university was using Scheme as the programming language. And it was kind of super interesting. Hey, this is kind of Lisp and you can do fancy stuff with this, but then it always felt that it's not like something you could easily use in production or build your web app or whatever. And then I kind of forgot the whole thing. And then when I heard about Clojure for the first time, maybe somewhere like, I don't know, 7 years ago or something, then I was like, this is running on top of JVM and can use all the Java libraries. And I already know Java, and now I have kind of this scheme on Java thing here. So let's try it out. And people were also, many people were kind of praising it, that it's simple and it makes things simple. And since it's functional, it kind of forces you to think in a certain way. And I was also kind of leaning into that direction during those times. And then I kind of found out the whole thing.
Awesome. Yeah, you already mentioned the JVM and the kind of the vast Java ecosystem that you get kind of as a bonus for writing Clojure. Then I've also heard that there's something called Clojure script. And since at least when I grew up, there was the JavaScript kind of debacle that was like having nothing to do with each other. But I've understood that Clojure and Clojure script are much more tied together. Can you talk a little bit about that?
Yeah, so Clojure script is Clojure runtime running on JavaScript runtimes, so either on the browser or on Node. And Clojure and Clojure script are pretty much the same language. They basically have more or less the same core libraries, but then when it comes to kind of using the platform-specific things, so obviously Clojure on JVM would use Java strings and Java data structures beneath the surface, and then Clojure script would use JavaScript. And then for some things you would use, like there's this library from Google that's called Clojure with S, and it's using beneath the surface like stuff from the JavaScript ecosystem to be able to do the same stuff. But basically it's the kind of why does it exist is that you could use you could build kind of full stack web applications with Clojure, so that you have Clojure running on the JVM on backend and then Clojure script on the front end, and then you could kind of interoperate very easily when you have all that. Can you basically use, for example, the same data formats that would be, you could use Clojure specific data formats instead of JSON, for example, in like communicating between front end and backend, but obviously you can use JSON as well.
Yeah, so it seems that Clojure it's quite kind of bubbling under technology in a way that it's not the most widely used, but it's still something that at least I hear about every now and then. There seems to be quite an active community.
Yeah, it's kind of niche thing, but then it stands on the big shoulders of Java, and there's like a lot of really experienced people in the community. So it's kind of, I don't know how to describe it best, but like as you said, it's like bubbling under. There's like a lot of power in the ecosystem and in the platform, but of course you have to make the kind of leap to the kind of, do I really want to use it in production stuff and like that.
Yeah, I definitely have great experiences with the Clojure community, at least here in Finland, in Helsinki and Tampere. I know some of the people currently joining in on YouTube are part of that community, so welcome to all of you as well.
And yeah, I would add one thing, that maybe Finland is kind of an outlier, that Finland has like one of the biggest Clojure communities per capita, I would assume. And that's mostly, I think, because there's a lot of active members who contribute in the open source. And there's like a big shout out to people at Metosin, which is a company based in Tampere, because they are building a lot of libraries and publishing them out in open source. So I think that's one of the reasons. And they've been organizing this Clojure conference for many years, and I think that's one thing as well.
Yeah, it's super great to see even the kind of smaller communities being super active, and that's a great testament for like not all communities need to be the largest one, but once you find the people who are excited about same things, coming together and doing stuff, that's really cool. So should we take a little bit of look of like what does Clojure actually look like and how do you write it?
Yeah. Oh my God, I'm live on my screen. So
and please, in the chat, let us know if the font size is good.
Yeah.
If it's too small, we can work with that.
So what I have here on the screen is IntelliJ which is a IDE, which is, I think, mainly targeted for Java and Kotlin developers, and it's of course running Clojure as well. And I have like a REPL running here, and I can write stuff here like, and then it evaluates them. REPL means read, eval, print. What's the L for? Loop, yeah, exactly. Then you go back to the beginning. So basically, I think one of the core things I'd like to have people getting out from this session is that REPL is one of the most powerful tool in Clojure development. And as long as you have like an editor that like integrates well with the REPL, then you're kind of set up for Clojure development. And like having the loop between your editor and REPL and being able to evaluate all the stuff that you're all the time developing makes Clojure really efficient to develop. And yeah, maybe we could talk a bit about the syntax maybe.
Yeah, and especially I think we have some people in the audience who might not be familiar with Lisp and those kind of languages. So one of the things often comes up when we talk about Lisp-based languages or Lisp-inspired languages is that there's a lot of parentheses going on.
Yeah, I don't think there's much more parentheses than in other languages, but it might appear so because they often stack. But like the thing is that everything is kind of lists. So the basic fundamental thing is that like lists always start like if you're, for example, invocating a function. So like I had the plus function and then I could give some parameters. So the first parameter is the function name, and then it just evaluates with those parameters. So if I just have the plus here, it shows me that it's kind of some kind of object. So this is now a bit showing about the Java side, but it's like this plus function there. And then I could have like, I don't know, str, which concatenates strings together. I could have here like, I don't know, stuff like this. And then when you nest things, you have like lists inside of lists, and then it evaluates always kind of the functions when you are starting a list. And then you have, if you want to have like a literal list, then you could like say either list, or then you could have this other syntax that basically quotes that, you know, do not evaluate this. And now you have like a list. And then I'm not sure if I know how to do this, but yeah, and I have like this stuff here, which is like the list that has this first element is this plus, and I probably can now evaluate this. Okay. So now you see that code and data are exactly equal in Clojure, and then you can just evaluate it because it's kind of interpreted on the go, or compiled and interpreted here on the go.
Yeah, and there's like I've been using Python a lot in my days, and it's one of my favorite languages. We also use REPL every now and then, but what I've understood is that at Clojure it's much more closely kind of built into the workflow. Yeah, it's not just like jumping between, but it's kind of working things in parallel with the code, and then kind of running the same files and working with REPL.
Yeah, we're living in the REPL, I would say. Maybe I'll just show shortly kind of other things than lists so that it's like familiar, that it's not like a surprise what is happening. So I think the three maybe most used data structures would be the list, and then there would be like a vector, which is just a kind of a better list because you don't you can kind of access in faster time like any element. So basically it's, I think it's some kind of Java array inside. Like if I say type, probably get, it's Clojure has implemented the persistent vector, but that's kind of the Java implementation, the name of the Java implementation there. And then there would be like maps. Maps would be pretty close to what maps are in, for example, JavaScript. So for the keywords, you would use this kind of syntax where there's a colon, and then you could have like you could have like things like this, and notice that you don't need the commas in between, even though the REPL prints them. And now one nice thing is that you can use the keywords as functions. So you could access the foo part of the map like this. So this is super nice for the developer. You don't need to kind of write any kind of function to do that separately. There's a lot of syntactic sugar here.
Yeah. Yeah, it seems to be that you're kind of using the same looking things all over again. And then the Clojure makes it nice to work with the data structure that you give it. So you kind of the accessing an attribute of a list or map is like calling a function.
Let's say we have a date, which is actually a string, but I don't mind. What is the date today? Maybe it's 21st, I'm not sure.
27th.
Oh my God, I'm living it last week. And then like, let's say show is Codebase, and then I would put like episode. So, and then I'll put like a map inside here, and then I'll like have episode ID 2 and title something. No, it's Clojure. So why I'm doing this is that you could then access, like you could first take the episode here like this, and then you could say like title, and then you could say like how many characters do we have there? We have 7 characters, and I wanted to show another syntactic sugar because it's so awesome. Now the thing is that you're kind of doing this here like in the reverse order. So then we have this kind of nice threading macro that you can kind of then first have the data, and then you have the functions that take kind of that data, and then you return a value. So like I get this, like, let's put episode here.
So it's kind of like chaining them together.
Yes. So now what episode is returning is going to be threaded to the next one, which is title, and then count. So sometimes it makes your code easier to read when you use the threading macro, and then you get into macros, and I don't want to get into macros because macros are a bit complicated, but macros are basically a way to kind of add things in the language. So you can basically add new syntactic sugar that, you know, whenever you get this expression, do something with the expression and actually run this code here, and then it would during runtime kind of change your code when you kind of use the macro. But macros are a really powerful tool, but sometimes might be a bit cumbersome, like a bit complicated, let's put it this way. So try to start to get things done before like going into macros without macros, is my take on that.
And maybe we can do a macro episode one day in the future if things go that far, but let's stay away from them today.
That would be actually nice, because then I should actually learn to use them, like to learn to build them, and then that would be like, I have to first do that. I think I have built like 1 macro ever.
Yeah. I'll give you a couple of seasons to wait for and practice.
Good.
Awesome.
So what do we want to do next?
Let's build something.
Okay. Maybe we could do that. I'll show one thing more. I'll just show functions, because we're talking about functional programming, and maybe some stuff about functional programming. How does it kind of convey itself here? Like, why is it functional? So the thing is, all the data that you see here is immutable. So basically all Clojure data structures, well, not all, but the most used ones, the things that I showed so far, you cannot change them. You can use things like assos, which would associate stuff with in maps. So if I have my map here, I could say like associate the date and put there like something else. Let's go into future. And then I could get like a new data structure, but this is not the same. Nobody's pointing to the same data here. So now I'm getting like a fresh map, which is completely different data in the memory. And this is kind of the basic idea that you couldn't introduce bugs which are happening due to the fact that like in one time point your data looks like this, and in the other time point it looks like that. So basically you're more or less building pipes that transform data, and then you get another instance out, and then your code in somewhere else would not assume that, you know, even if it assumes that the data is the same, it wouldn't break, because you're not actually changing the data. And like,
so every time we run a function with the same input, we can expect the same output.
Yes, obviously you can introduce state there, and obviously you can do stuff like that. But let's not yet go there. I'll just show, like, this is you can define more or less constants with def. and now you're binding this with a value, and then you could like use defn to define functions. So let's put here like, I don't know what, increment 2, and then it would say plus 2i. Now I could call it like this. And then, as we maybe have seen, it's not a typed language, so it's not like strongly typed. You can give whatever you want to there, and now during runtime it will shout to me that Java lang string cannot be cast to Java lang number. So it's like dynamically during runtime checking that, hey, this is not possible.
Yeah, now we also see the underlying JVM, the Java ecosystem in the stack trace.
Yeah, so it's an exception. It's a Java exception, and there's Java lang number and Java lang string going on. But it's the Clojure compiler that's saying me these things.
So, would you say that somebody who doesn't know Java, can they get into Clojure? Or do you, like, how much do you benefit from knowing Java beforehand? Is it a requirement?
This is an interesting question, because I had programmed many years with Java before jumping into Clojure, so it's kind of hard to say. But I know for a fact that I, for example, have a co-worker who hasn't developed Java professionally and basically has more or less developed only Clojure and ClojureScript, and he's happy with it. And obviously, I think during the course he has learned bits and pieces about the Java ecosystem. But I would say that, of course, it helps, especially when you need to write code that interoperates with some existing Java stuff. But like, depending on what you're doing, more like there's huge amount of Clojure native libraries where you don't actually need to know anything about the Java. Of course, when you want to get your things up and running, depending on where you're running your software, you might need to know like how to set up JVM or how to set up, memory settings for JVM or stuff like that. But then again, if you're running, for example, at Heroku, you would just, write your Clojure app and say Heroku, how do you say, git push Heroku master, and it already supports Clojure, and then there you have it. You don't need to actually know anything about Java.
Yeah.
That's how I started.
Yeah. Do we have anybody in the chat who is also doing Clojure and has either strong Java background or started fresh with Clojure? Let us know in the chat.
I'm pretty sure there's actually one who has background. Let's see if they want to expose themselves.
Yeah. All right, so now we know kind of the basics of calling functions, some of the base data structures, the functions. Is there something more on the kind of introduction to Clojure that people should have some kind of idea of?
Well, I could maybe show. Yeah, the thing is, I don't know how long I want to go within, because I could of course introduce all the stuff, but I'll actually write this increment 2 in a much more fancier way. So I would say actually def, and I would say here partial plus 2. So this is kind of a bit showing the power of Clojure in the sense that I'm not actually defining a function that takes arguments, but I'm binding this thing that partial returns, and partial returns another function. So this is maybe that part of functional programming where you have functions as first-class citizens. So you can pass functions as parameters. So partial is making a function out of plus 2 so that it's giving plus this number 2 as an argument, and then whatever is given to this thing here is then given to the plus. So I could say increment 2. Oh my God, it doesn't work. What did I do? I thought I could do this. I need to try it out. Like if I make partial, then me.
Needed to close the window. There was some helicopter running
This
over.
is a bit actually.
This is the classic demo effect when you do things live. Sometimes it doesn't do. And while you're thinking about that, we
should have tried this before. The thing is that you can call plus with only one argument. So it actually, this is what I did wrong. This is what I wanted to do. Yeah, I was already here evaluating the plus function, and now it evaluates it already there because there's the parenthesis, and then what you get out of the innermost parenthesis is actually already 2. And I wanted to have it like this, and now I have the function plus with. I'm just so bad at this. So now it works.
Awesome.
Just had to look at the code for a while.
Yeah.
But yeah.
All right, I think we could now jump into. We have a little bit of an idea of what we want to build. So
yeah.
Do you want to tell a little bit of a background of we talked before the stream that there was a little bit of a story. This is kind of similar to something that you built early on into your Clojure journey.
Yeah, so basically what I have here is a kind of a code base that was created from a template that has a few libraries put together so that you can easily build a web app. And there's already the link. So basically, in that link is actually the end result where I'm trying to get today. But let's see if I get there. And we're using this Clojure build tool called Leiningen. So we basically have Java and Leiningen installed, and then you can basically set up this stuff yourself. And I kind of wanted to show how to build a simple web app, because in my opinion, it's really easy to get started and just start building stuff. So maybe the backstory you were referring to was that at some point I was also working as a consultant at Futuris in my past, and I was in one project where we wanted to build a really simple web app for a project where there were like mobile apps being built on different platforms, and we basically wanted a web app that would kind of get input from different sources and then mangle them to make a nicer kind of API for the mobile app, so that we don't have to do all that kind of data transformation in all the different platforms. That was during the time when mobile apps were built on 3 platforms. And then a coworker called Juha Leppilahti said to me that, hey, let's build it on Clojure. And I was like, are you sure? I haven't done it before. And he was like, yeah, it's good, just do it. And we were kind of contemplating whether we should do it on Clojure or on Node. And then I talked with another coworker who had done more work with Clojure. Shout out to Juho Vähäherttua, who then kind of said to me that, yeah, do this, don't do that, and you'll be fine. And then I just started building it. And the funny stuff, like what was so nice for me was that during the first day, I was able to kind of set up a template like this. I could start using like some endpoints that existed, some APIs that existed. I could get data in, I could do something with the data, get data out. And already during the first day, I felt that I had like a kind of a MVP of my API done, and I could start kind of having a feedback loop for myself, kind of getting code in, having code running somewhere, and then also for my co-developer who were doing the mobile apps, they would also get like instantly something out of it. So it would produce value super fast. And that was kind of my first jump doing Clojure in production. And then, of course, it helped a bit that we could put the first version in Heroku so that I didn't actually need to kind of set up all the environments. But then later on, of course, the customer said that, no, you can't use that. You should use our servers somewhere. And then we had to fiddle a bit different things. But
yeah, so basically you were building this kind of like a middle backend kind of thing for like getting different sorts of data in, putting them into one or multiple endpoints, and only providing your mobile app with the data that it needed.
Yeah,
in
so
the format that it could use.
Yeah, the developer in the project, Juha had already built like the app for one platform, and then when he started building for the other platform, then we kind of saw that, okay, the API was not as nice as we thought, and there was a lot of this mangling happening in the app inside, and then we thought it doesn't make any sense to do it many times into different apps, and then instead it would be much easier to make like this kind of middle back. And then that was also like learning experience in another way, because I learned that whenever you're building mobile apps, it usually makes a lot of sense to have like a dedicated backend for those apps, because then you can control stuff what goes to the mobile app. So if you have like some external sources, you probably are not fully controlling the data. And then if you have, for example, a bug in your mobile app, you can instantly do stuff with the data, like fix this data right now and your app will be okay. Instead, if you're just relying on the good data you get from the good backends, then if you have a bug in the mobile app, you will have like a long delay until you get your new app version through all the processes of app stores and stuff. So this is also a nice thing. Doesn't have anything to do with Clojure, but
yeah. So can you talk a little bit about the kind of IDE setup that you have? Now you already mentioned that you're using IDE, but what are we looking at in the screen?
Yeah, so basically I created this new project with this build tool called Leiningen. So there are, I think, 3 different build tools for Clojure, and I've been mostly using Leiningen. And then I used this template that was kind of basically giving me all the stuff that you see on the screen. So basically it more or less has this one file, which is called main.clj, and it has here like stuff that's required, like libraries that we are using. And then basically it's using this, the main library here is called Reitit, which comes from Tampere, from Metosin. And they basically built this thing that is routing library on top of an HTTP library, and the HTTP library here is called Aleph. And here, I think this routes definition is the core thing that, it says that when you're in the root, you would kind of serve get requests with this handler called home handler, which is this function here, and it gets this request as a parameter, but it doesn't use this request, and then it just returns hello world. And I could actually put it up and running. So now that I have my REPL here, the fun stuff is that you can just call code from, I think I have this namespace already in the REPL, yes. So if I like type here, the IDE tells me that there's this kind of function start server. Now it says starting server on port 3000, and I can see that, yeah, it returns hello world in the browser. And this is basically where we start at. And I had an idea that we could do similar stuff as what I was like explaining, like getting data from some API, doing some stuff, and then sending it out in our API. So my idea was that we would use this kind of open API called MetaWeather that kind of returns weather information.
So it's the kind of API that as time goes on, especially during this time of the year, the results get better.
Yeah. So I actually already put these libraries. These libraries are included in the thing, but I could start like putting up a new endpoint here. So obviously there's a lot of syntactic stuff here. I'm not gonna explain like why things are built in the way they are, but let's put here like if we are doing this imaginary weather API, and then we'll do get requests there, and then we'd make like another handler. See.
And if there's something that you see on the screen, for the people who are watching, if there's something you want to know more about, feel free to ask on the chat. The idea of this is not to kind of go step by step, a tutorial type of thing, but mostly just kind of give you an idea of what it looks like to build apps with these technologies. But that doesn't mean that you're not allowed to ask. So that also gives us a good point of reference for kind of what to talk about. So if there's something you're interested in more, just ask on the chat, and I will put you under the spotlight there.
So what did I do? Oh yeah, I don't have right number of arguments. So there's a underscore here, which is kind of Clojure way of telling the compiler that it takes an argument, but we're not using the argument. So don't kind of bother trying to say to me that you're not using the argument. Also for the editor. So it's always returning this map. And what rated is doing behind the scenes is that it's basically putting those things in the map into the response, and it should then serialize this inner map inside the body as JSON. And now I pressed something like Command-Shift-L here, which kind of reloads this code in the REPL. Now it should be also running in the web server. So this is the nice thing about running your web server in the REPL, is that whenever you develop your code in the REPL, it's already running in your server at the same time. So now if I reload the document here, I need to go to the right. I have stuff here, weather. Let's see if it works. Oh, so I have this filter, like this plugin in my Firefox, so it shows that the raw data looks like JSON, and it is JSON because it shows it like nicely like this.
So you don't need to kind of always restart the server as long as you reload the new file on the REPL, and that takes care of it.
Of course, there's like limitations there. So if you add stuff, it just compiles more and more stuff, but it keeps in the memory all the old references and all the kind of names that you have bound to. So if you kind of do something there, it will stay there. And then if you try to reuse stuff, I mean, you might end up in a situation where you have like old stuff running there, or old stuff like bound to names, and then you're like, where did this come from? And then you need to restart the REPL to have a clean state, obviously. And another thing is that if you require new libraries here that you didn't have, that's actually okay for the REPL. But if you go to if you change your project definition, so here's what actually is, here's like how it's defined. So there's all the libraries that are actually fetched from the kind of repositories for Clojure for Java. And if you kind of add something here, a new library, then you actually need to restart the REPL, because that's something I think, the thing is, I don't know how to handle that, but I think it's better to restart the REPL when you do that. But yeah, let's try to do something like more or less real. So there's actually this method called http get, I think. Yes, and you can make a request to some kind of URLs, and let's check the URL here. So there's an example of London. Let's like call it with the browser. So this is what the London endpoint returns here in the browser. And if we go to we put it here. Now this library is interesting because it actually returns a promise, but let's not go there. We just dereference it, and we should get something out of it. So we get kind of this map that has all the stuff about the response, and it has this thing called body here, and then you can see that, okay, that Java is all again jumping on me here. So I'm actually trying to read out stuff from that one. So if I check the body, this is what I get. I'm doing all the time HTTP requests here, by the way. I could actually be a bit more wiser and maybe say that this is the London thing, and I don't have to make requests all the time. Let's put this a bit broader like this. So now I have this request save here, so then I have to all the time make some DOS request to somebody. Now I have to kind of check what I was doing. I don't remember how to use that byte streams things by heart. Let's see.
I'm also happy to see the mention of the Metasin libraries also on the chat. So people are, it's like you said earlier, the open source community in Finland is strong with in the Clojure world. So I noticed that bunch of the library names that you imported are words in Finnish.
Yeah, it's a surprise that it's funny they have all these things. So there's this thing called ps2string, which actually reads this byte array stream and then make a string out of it. And then I'm gonna use this thing called JSONista, which is a JSON serializer. And they have this thing called read value, and it takes an object which is in this Oh, it needs. Let me check. Do they have like read string? This is what I actually ended up doing. There's probably other libraries that are easier to deal with here, but I'm just looking what I used before. So let's see if it works. Yeah. So here's basically the same stuff that we saw in the browser as a Clojure map. And now I could actually write this stuff as a function here in the source. So I could make this kind of function, which is called, let's make it like get weather. And it takes it doesn't need to take actually parameters because we can go into that later. And instead of London, we're doing this HTTP get, and the URL was here. So now I probably can test that it still works. So if I send this to my REPL and say get weather, yes, I'm getting the same stuff out. And now I had an idea that we could calculate some temperatures out of this thing so that we could actually get into some data processing here. So there's, there was actually another endpoint that I was using when I tested this. Oh yeah. So I'll try to rewrite some stuff here. So actually I had this, there's another endpoint that is able to serve like history data. I think it's down here, yeah. So there's this thing that if you need to give this ID, which was the one that we saw for London, and then if you gave this kind of date here, then you get kind of weather from this time point backwards. And I was thinking that we could check like what was the average temperature during the time that the API would serve, so that there would be some kind of more interesting data going on there. So I'll just kind of copy paste a bunch of stuff here. So this is the weather URL, and yeah, you need to have the actual, let's make this a function. So we need to have this kind of date in the parameters. And this is where one spot where I wanted to actually show how the Java interrupt works. So now if I want, in addition to the libraries, have like import some Java stuff here, I could import Java time offset date time. And my code is not running. So now if I call this Java thing here, there's a static method called now. It will return me actually a Java object. And this is like now how you use Java from Clojure. So you basically can just instantiate objects like this, and then you can call methods of that object by having them, like the method name is first, and then you take as a parameter, the first parameter is more or less the this. So then it will kind of instantiate this now, and then it can kind of, you can get things out of like that.
I really like the way they are kind of, like you can use it with the like Clojure style. So yeah, you don't have to write Java's, like Java-esque inside your Clojure.
Yeah, it's much more concise, and you kind of, all the verbosity is thrown away.
Yeah.
And now I wanted to put this behind the URL, and now I'll basically say here like let, and let makes you bind like more or less local variables instead, but they are not variables, they're like locally bound constants. Let's put it that way. So now I could say like now is offset date time now, and then I could say this returns me a string where I have this URL here, and then in that, then I could like have get, first I wanted to have the year, then I have slash, and then I wanted to have like month value, I think. Then I would like have day of month now. And this should allow me to call weather URL. Now I get like a nice URL, and now I need to actually call it like this. I could actually put the location like the city ID or something like that here as well, because that's, we want to parameterize anyways at some point. And then after that I would have a slash. Now I need to check what was the London ID. It was 44418. I have it here as well. So I would then, now it says me that, yeah, I'm missing a parameter, the arity of the function like is not 0 but 1, so I would put here like for this 44418. Let's check that if this still works. So if I call this, yeah, the URL looks nice, and now if I call get weather, still get weather. Now I get like the different kind of data structure out, where I have actually I can see from the bracket here that actually I'm just getting a long vector. And now what I could do next is that I could try to kind of learn in the REPL that what is the data that I have like. So if I put here like def London weather, so now I have this London weather, and then I could start like reading like, okay, so what's this London weather like? So if I put like count, I will see that, okay, there's 56 elements in my vector. If I say first, doesn't look good. Why I'm getting that? No, because it was the URL I was getting here. So I was counting the strings. Get weather is what we want to do. Oh, I've copy pasted wrong stuff. So let's so you can basically rebind or like def things again, and then you just, so actually we're having 69 samples in our vector, and the first one looks like this. So there's lots of data, and we probably are not interested in all of them. So I was thinking, let's calculate something about the temperature. So it's called the temp. So now what I can do here is I use another macro, which is these two arrows there, says that, take the function that you have in the threading macro and put that like kind of as the last argument, what you get from the previous threading. So if I call map, and now map takes a function and applies that function for each element in the collection. And now I have vector of these map things here, and I want to call the temp. And this would now, as I showed in the beginning, that the temp acts as a function. So the keyword would then access that element in the map. So I would get like a huge list of temperatures. And what I could do with these is that I could calculate them together and then maybe calculate the average. So let's maybe put it here in my function. So, well, I'll write it here. So if I want to calculate them together, then I would, of course, use reduce. I would give the parameter plus. I think it should just work. Now if I like divide this thing with, I think it was 69 elements, and the average temperature should be 13 if I like had it right, but I could just add it here.
I think looking at the data, that sounds quite nice. I think the fact that the keys of the maps function as a function, it makes the mapping look really nice. Like that's kind of blocking the certain elements out of the objects. That's definitely something that in other languages I wish that we had much more often than not.
So let's make a get average temperature. That would like first get the kind of weather data with get weather, and then we kind of want to calculate the average. So let's put like Yeah, well, we can just calculate it like here in the body. So we could just have the thing that I was having there, like weather data, then map the temp, and then reduce plus. So what it actually does here is that like map and reduce takes the last argument is the collection that it uses. And then I would, maybe this is the, well, I'll name it. It's actually easier to read if I name it. This is like temperature sum, like this. And then I would add the division here. So temperature sum divided by the count of weather data. Should this work? What do you think?
I think it looks quite nice.
Get average temperature. Ooh, we get the same result. So now we could actually also return it here. So we could have like our weather handler says average temperature. You might notice that all the function names and all the kind of local variables I use have kept uppercase. So that's like the Clojure idiomatic way, but I think, I'm not sure what is the Java. Maybe in JSON you should use like camel case. Then it
JSON is using camel.
So you can of course use camel case in Clojure, but usually we use kebab case. And then of course there's a library that converts your stuff between kebab and camel and shouting and whatever case there is. And then when you're doing data mangling, you of course do that as well.
Yeah, that's one of the things with JSON that I've been myself working with Rust lately, trying to learn the language, and Rust wants to use snake cases, and then you get JSON that is camel case.
Yes.
And when you make the like structs to define the like structure of the JSON, then my editor is always complaining that like you need to use snake case.
So we have like a project. Participating in a fun project like just now in work, and we have like database where you have, of course, in Postgresql you have is it called snake case, the one in the bottom? Yes. So we have snake case there, then we have JSON, which is of course a camel case, and then we have Clojure, which is kebab case, and then of course we all the time like switch between these, but we use a library for that, so then we don't have to do it manually. So it's getting out from the API. And now the fun thing, like we can look here that, hey, how many rows of code we have? We have like one screen full of stuff, and now we're already getting data in, doing some mangling and getting data out. And this is like what's fun about Clojure.
Yeah, and I really like the way that you developed it in the REPL and then just kind of copied the good stuff into the code. So that, or the file. So that it's kind of you don't have to write it first and then check if it works, but you can kind of first make sure that it works and then put it into the file.
I had an idea that we could kind of make it so that we could also get the Helsinki weather out of there. So if we do this location search, should we do that?
Let's do that. And before we go to that, if there's anybody who has joined within the past like 30 minutes, this is Codebase. Today I'm joined by Yrjö, who is a software developer, Clojurian, and a podcast host. And for the past an hour, we've been talking about Clojure, and Yrjö is showing us how to build a kind of a middle API between getting data from weather API and only picking up the stuff that we actually need. And since you are pretty much watching this on YouTube, if you want to join us also in the future to learn about more different technologies, hit the subscribe button. And if you're watching this somehow somewhere else lately, head over to amatti.org/YouTube and you will be able to make sure that you don't miss any of the other live events. So yes, how can we get the local weather on Helsinki?
Yeah, I actually started coding as already. I made the city URL that just puts the city in the URL. Of course, you shouldn't do this. I mean, if you get the city as an input from user, you shouldn't just use it as is in your requests, because now anybody can, input any kind of nasty stuff there that might not be nice. So of course you should sanitize always your input, but I'm not doing it now.
We need to bring in the caption that we also used last month. Really, like,
yes.
Don't try this at home.
And now I will make this more general. So let's put this like API get. So this is like making the API request, and it takes the URL as a parameter. So then we don't have to rewrite this code in many places. And now that we have this get weather here, this could take, no. We could have this take like the city ID and just maybe call this API get with the weather URL and give the city ID there. Now if everything is...
I think from the API get function you forgot the URL on line 14.
Yes, I did. Thanks. But okay. Yeah, get weather city ID. And now I need to somewhere grab my city ID. I don't remember anymore. What was it? Oh, let's check it out here. So London was 44418. Yeah, my code still works. The old code still works. And I could then kind of put one function here that's called get city ID. And this would take the kind of city name. And then this would call the API get. Let's see. Yeah, actually I need to first try it out in REPL. So there's the city URL. So what does it actually return to me? So if I say API get and city URL and Helsinki. So this is what I get. So I get an vector that has one element, which is a map. And then it has this where on earth ID, which is the only data that I'm interested in. So I could just, I can just write it quickly. I would say for this, maybe, I don't know, first. Then I could say maybe this way, or thing like that. So yeah, that's what I want to get out. Obviously, now you can see here that already I'm doing this. Now there's the kind of thing that somebody says, oh my God, there's so many parentheses. And then I could like, yeah, we can do this like the other way around. And then we have like not so many parentheses because like, why not? Did it work? Oh my God, it works. So we could just put this here.
So which one do you usually use? Or does it like depend on the case?
I think if it's just like two functions, I would not use the threading macro because depending on what you have inside, it can get like not so easy to read. But if I have like more stuff, then I would use that. And there's a huge amount of different kind of threading macros. There's like a conditional macro that you start with a like for example a empty vector, and then if you can have like conditions here, like if 1 is 1, so there's got some kind of test, and then if 1 is 1, conjoin, put in that vector like first element, which is like something like this, and then you get like it's added there. But if your test is not true, you would just get passed through the data. So you can kind of change stuff, and then depending on what your predicates are here, you would kind of add data. So there's a lot of these kind of nice things that you can use.
Are the threadings, are they purely syntactic sugar, or does it affect the like performance or something like that?
They are macros, so it doesn't affect the performance, but then you might end up in problems if you put macros, if you like use threading macros inside threading macros. There's sometimes some corner cases where the macros might not work correctly, but I'm not actually sure. I have even stumbled into those. I'm pretty often using them. But hey, let's see if my city ID still works. So get city ID Helsinki. Okay, and now here's it's already saying to me that my get average temperature is not having the right arity in this function call, because this wants to have the city ID here. And we could take the city name as a parameter, but let's put here the city ID first. So it's calling this get city ID and then city name. And now I need to see how I check the path parameter. So my idea was that we could give it as a path parameter. So we could have like city here. And now what this does, Rated does some magic behind the scenes. So there's this weather handler will get a parameter now. It's the request object. And there's a nice destructuring syntax. So I could kind of have the request here. And then I could say that like read from the request. Well, I'll do this first. It's nicer. So from the request, I get first path parameters. Maybe I should just print out the darn thing so we'd see what happens here. So I could just do this old-fashioned thing here. Let's put like Helsinki still here so that it works. Yeah. So now let's see what happens. I have this println here. Now if I do this request, let's see. Let's put here like Stockholm. Yeah, Stockholm has been a bit cold lately, but that's not a surprise because Helsinki is cold as well. And now if I
I'm
look
starting
here,
to feel jealous for people in London now that I'm
I
seeing the other numbers.
I maybe don't want to have. So there's a lot of data here, like it looks like a mess. But if you look very carefully, you can see that actually it's a map, and there's just a lot of rated internal stuff. And I think if I search here something like path, yeah, there's like the whole path is Api Weather City, and if I think there should be, yeah, there's path params, which is a map inside the map, and it has a one key which is called the city, because I here already told me that rated that I want to have this parameter. So I could now grab from the request here. I could say that, hey, let's give path params and city, and then give the request. Yeah, that, and now, I still need to give it here, city name. See if it works. Yeah. So now, actually the 5 point something was Helsinki. Stockholm is 6 because I had already hard-coded Helsinki. We lost this game, darn. Feels bad. Well, anyway, so Stockholm is having 6.8 and let's put London again here. It's still 13, so right. Now we have an API that takes arguments in the URL, and we could also maybe add the city. How do we do that? Maybe I'll just I wanted to kind of show the destructuring syntax. So instead of reading the request, the whole map object, I could use this nice thing that destructures maps. So I could say that I know that in the map I have a thing called path params. And now I already have like one less thing here. So I already have like a local variable with that name. So you can do stuff like that easily. And of course, the thing is here that how do I know that I get that data in? Now, this is the trick here. Of course, since it's not strongly and statically typed, you don't know for sure. And now the thing is that when you're building more kind of production kind of code, you would actually need to build things that would make sure that you're not writing bugs. So basically, you could have like a schema validations there. So there's different kind of schema libraries. I could actually have, for example, here. I think Rated already has like an interoperates. I could like have here parameters. I could have here like a structure that tells me that this is the form of data I'm expecting. So then it would do kind of schema validation when I get schema in, and then I would know that, okay, what kind of parameters I get in, and I can do the schema validations in the function calls as well. But I'm probably not going into that at the moment. And then, of course, I would assume that people end up writing more tests, like unit tests and stuff in Clojure, that they would, for example, in Scala or Java or Kotlin, where they would have the typing as their friend doing part of that job. But you cannot, of course, compare them one-to-one because, yeah, it's a different approach. And of course, with schema, you can write much more elaborate validations than with just types. But then again, you don't get the benefit of compile time checking because schemas are validated runtime.
Yeah.
So it's apples and oranges. I'll check if this still works. And we could, like, what would be nice city to try? Something that we would be really envious of.
Do we have somebody in the chat whose home city hasn't been looked at yet?
Even Moscow is warmer than Helsinki.
Yeah.
Let's put like...
How about Tampere?
I think now we're getting to something interesting because I think Tampere is not actually in the API, and we probably will something bad will happen. Let's try it out. Oh! So this is a good example actually, because now we see that, okay, my code is not robust. It prints me an exception here, and obviously because it's a dynamic language, you can do stuff that won't work. And obviously this is not how I would write it in production. Obviously I should probably check if the city ID exists before calling the get weather. And I need to think, how would I do it? Actually,
this is the first time I'm hearing about the does Tampere exist?
Yeah.
Like conspiracy theory. I've heard about the does Finland exist, but now we're into the does Tampere exist.
I could actually get the city ID already here in the handler, so then it's a bit easier. So let's put the city path bottoms. I'll actually write it also here. So city name is city path bottoms. Then I would have like if city ID. Then I'll put this here, and this would actually have the city ID. So this function does not need to be here anymore. We're actually giving the ID. And then, if not, what then? We can return status 404. Would this work? Body. Error. Close, but no cigar. Is that good?
That looks nice.
Close, but no cigar.
How about our friends in Munich? I know that you have you and Munich also share some history. So.
Munich is warm.
Yeah, they are almost at the summertime.
Yeah, they are.
I think last month when we talked with Fotis, it was like one of the first weeks of official spring in Finland, and I was really devastated to learn that the kind of ambition levels are low. That spring is defined as like over 0 degrees Celsius. And I was
the average temperature. Yes. Yes, and I think for Munich that's also something like end of the winter. This temperature. I mean, like usually at this time of the year it's much warmer there, but I think there's some kind of cold front on Europe here. But yeah, this is actually nice that it worked so well. So probably what I get here is that I get like in this where I call this API get here, it actually like if I try it in the REPL, I can see like what the hell happens behind the scenes. So this get city ID. Let's clean up this mess. So so I have like my city name, which is like Tampere. Sorry for the people in Tampere. It's not my fault. I'm just using a crappy API. I know that you exist. Don't get me wrong. So my URL is right, and then if I say API get, the API is actually nice. It returns me empty, like an array. So if I then say first, I will actually get nil, and then if I say something on the nil, I all the time get nil. So this is like called nil punning, which is the fact that unlike in some other languages, like in Scala, for example, there's these things like maybe, where you kind of have these monads that either have data or like no data. But in Clojure, you wouldn't have that. But then instead, most often the way that things are handled is that you kind of, if you get nil, you can just pass it through, and then in the end you just get nil, and then you just have to, at some point, you have to kind of check, do I really have data here or not? And of course, I can't do like always reasonable stuff with nil, but like in this case, it was kind of pretty nice way to handle the error, because I got empty data, so obviously nil is okay. I get nil as the city ID because city ID is nil. For some people, it might be terrifying because in Java you would all the time try to avoid the nulls.
Yeah.
But in Clojure, we kind of embrace the null, and then we just use the kind of methods that are okay with that.
Yeah, I think it's really interesting to see different languages of like how they are designed around the nil. Because like maybe this show should have been called null or not null, depending on which languages. Because then again, like I said, I've been learning Rust lately, and there, like, the concept doesn't exist, and it's kind of complete opposite of like, let's make sure that everything is something or none, which is the kind of equivalent, but it's something that you always need to. You have options that you need to deal with, and it's really interesting because there's no right or wrong answer. There's just like different approaches and different ways of like it leads to different types of solutions and ways of approaching the problems. So. And I think that's why it's great to kind of have this kind of show where we can see different languages and how they are designed and how they are used and what differences there are.
And I think like using functions from the Clojure core is pretty nil safe all in all, like in general. But then there are some gotchas if you use like Java methods for some stuff. So inside Java, then like the Java way of doing things is not usually null safe always, and then you might end up, if you like mix and match, like let's use Clojure here, let's put Java stuff here in between. So then you have to be a bit more careful. But if you're using Clojure things, then I would say like you can do things like this. Of course, you saw that my application broke when I didn't check that in the end that I was putting actually. Then probably I had the nil city ID, and then when I tried to get the temperature, of course I got something nasty out of the API because the API didn't want to get the nil as the city ID.
I think we are starting to get to the ending of the show.
Yeah.
If somebody wants to check out the code that we've been working with, or Yrjö has been writing, you can find it on github.com/Yrjö-Kari-Koskinen/hello-codebase.
And the fun thing is that's the thing that you see there in the kind of tip or the head of the main branch is not the same as here, because I already made a kind of fast implementation with different, like trying out similar stuff and a bit other stuff, but I think it's close enough. Like if somebody checks out that, they would kind of
then you can see a little bit of like both, a little bit of different ways of doing that. So I'm gonna put away the code. It was super nice to see how Clojure is written and how the kind of living in the REPL world works. Super nice that you joined. Feel free to follow us both on Twitter. I post stuff about technology and community and occasionally some memes. I think Yrjö also does similar types of things.
Yeah, I think I post probably more stuff on Clojure than you, but mostly, like other than that, I think mostly tech stuff. Sometimes maybe some Finnish silly things, but mostly English, sometimes Finnish.
Yeah. And I'll chat with you after we now got excited about getting into the first steps of Clojure. What do you recommend they do?
Oh, install Java, because you need that to run it, and then install some build tool, for example, Leiningen, and then fire up a project and start working. You don't actually need. You don't need to set up an IDE with all the fancy plugins if you don't wanna, but of course it helps. But I mean, you could just run the REPL on the command line as well. And I think we could maybe link some kind of Clojure tutorials, like in the show notes or whatever, wherever it will go. And I think it's pretty easy to just like fire up a REPL and start trying things out. And there's like one thing that actually now came into my mind. If you like wanna first just learn the syntax, there's a thing called Clojure Cones, like KOANS, and that's a site where you can kind of, there's like a lot of exercises where you kind of try out different solving really small puzzles, like doing functions, stuff that I did actually now in the REPL, like similar kind of things, getting used to the syntax, and it's really nice to kind of just go through those, and then you will kind of learn the syntax if that's something that you need to do.
Yeah, I find that a really nice way of starting to learn something. It's like little by little, and then especially with Clojure, it seems that like it's easy to expand from that. You start from the REPL and then you build on top of each other, and
I think like if you then bump into problems, then you could check out the Clojure community. So we could link both like the international and the Finnish community in the notes, and there's like people chatting in different forums like Slacks, and there's a Discord for Clojure discussions and whatnot.
Yeah, absolutely. I'm always a big advocate of people joining the communities. I think that's a really great way not only to learn and have people you can get help from, but also to meet people like you can, and like people who have been joining the chat today on the YouTube. It's so much more fun when you do things together with people, and you don't have to get stuck alone. Because when you're doing software development, you eventually get stuck at something, and then it's nice to have people.
I'm hoping that we could restart some live meetups this year already, but let's see how the vaccinations go here in Finland. But I'm like, at the moment, it looks like that maybe during the second half of the year, like maybe in the autumn or later this year, it could be even possible to kind of have. We had like about 1 year ago, we had a few online meetup sessions with the Helsinki Clojure meetup community, but then, well, that faded away after a few sessions, and I think people are more or less waiting for the opportunity to see like live and have some chats live and maybe some refreshments together and stuff like that.
Yeah, I'm waiting for that for so much. It's one of those things that it's online events are okay, but nothing replaces the fact that you can sit down with people and talk about life and technology and maybe grab a refreshment and learn something new from people. But yeah, thanks so much, Yrjö, for joining. It was super nice. Like 90 minutes to chat with you, as always. Always a pleasure. Yeah, follow Yrjö on Twitter, and if you speak and understand Finnish, I can highly recommend the Koodia Pinnan Alla podcast. I'm a big fan. I listen to it every time it comes out.
I think we're gonna publish the next episode like maybe today or tomorrow. So
you managed to do the re-recording?
Yes. We had a fun thing that we had a guest and host with the same name, and they both logged into the online like recording system with the same name. And then after the podcast, we had like, instead of 3 tracks, we had 2 tracks. So
that's the demo effect. That's technology for us. Yeah. So,
hey, well, thanks a lot for inviting me. It was really fun.
Awesome. I'll see you around, and everybody who joined. Next month, we're doing something new with some new technologies. Follow me on Twitter. Subscribe to the channel. That's how you're gonna find out what's happening. And then, of course, I'm on the.org/codebase. Codebase. I will update there as soon as I've agreed with the next guest.
See you. Bye bye.